Alright, let's see what is a homogeneous equation. Homogeneous equation is a differential equation when fx equal to 0. So we can write the second order differential equation for homogeneous equation as ax d square y over dx square plus bx dy over dx plus cx y equal to 0. And this equation we call homogeneous equation, especially when ax, bx, and cx are a constant, which are numbers. We can rewrite this equation number 2 into this equation. Ay double prime plus by prime plus cy equal to 0. So ax, bx, and cx are constant. Auxiliary or characteristic equation. Auxiliary or characteristic equation is an algebraic equation of degree n upon which depend the solution of a given n-order differential equation. Auxiliary equation is used to solve second-order differential equation. We begin by considering the second-order differential equation below. So let's say we have an equation ay double prime plus by prime plus cy equal to 0, which is equation number 2. So this is a homogeneous equation where function a, b, and c are constant. The solution of equation number 2 is assumed as y equal to exponent mx, where m is a constant. So you can prove the equation, the solution is y equal to exponent mx, where m is a constant. So from the solution y equal to exponent mx, we can find its first and second derivative. So from this solution, y equal to exponent mx, the first derivative are y prime. So we differentiate the solution, we get y prime equal to m exponent mx, and we differentiate second time to get a second order for y prime. So we have m square exponent mx, and then we substitute back the solution and their derivative y prime, and y double prime into equation number 2. So now this one will become a multiply y double prime, which is m square exponent mx, plus by prime. Now y prime are m exponent mx plus cy. Y is the solution, which is exponent mx, and this equation are equal to 0. So because we have exponent mx here, here, and here, then this exponent mx we can factorize, and then we can rewrite in the bracket am square plus bm plus c. So from this equation, we now can factorize to get this equation. Because exponent mx is cannot be 0, so whatever values m you substitute here, you cannot get this equation. This exponent cannot be 0. Then in order for this equation to be true, the bracket am square plus bm plus c must be 0 in order for this equation to be true, because this one cannot be 0, and this one must be 0. So 0 multiply this one, of course, equal to 0. So now that's why we have this equation 0. Equation in number 4. Equation number 4 is called auxiliary or characteristic equation, where m is roots of equation. Because we know the solution is y equal to exponent mx, which is m are unknown. So the solution to this equation is exactly the characteristic equation. This one, am square plus bm plus c. Now, because this is quadratic equation, of course, you can find the roots of the equation. We can find the value for m. Alternatively, equation 4 can be generated by substituting y double prime equal to m square, y prime equal to m, and y equal to 1. So you can directly change the equation 2 to equation 4 by using this substitution. The roots of equation m can be obtained using factorization of quadratic equation or by using calculator. So the solution to this equation, you can use the factorization or you can use quadratic formula. Minus b plus minus square root b square minus 4ac divided by 2a. Also, it is faster if you know how to use the calculator. So because this is a quadratic equation, there are 3 cases for values of m. So when you solve the quadratic equation, you will get either case 1, case 2, or case 3. Case 1 is when the values of m are real and distinct. That means you have different values for m1 and m2 because this is a second order differential equation, of course. Sorry, this is second order quadratic equation. This is quadratic equation. Of course, you will get 2 values of m. So the first one is m1, the second one is m2. So the case 1 is when m1 not equal to m2. That means you have 2 different value of m and both are real numbers. This is if the case root is b square minus 4ac. B square greater than 4ac. So if you get the case 1, then the general solution is the linear combination y equal to a exponent m1x plus b exponent m2x. Case number 2, where you get the roots real and equal. That means when you solve for m, you get the same values for m1 and m2. This is if the b square are equal to 4ac. So when you get this case, so the solution you can write as is y equal to a plus bx exponent m1x, m1 or m2x. And case number 3 are when the values of m are complex roots. So you have 2 values. First one is a plus alpha plus beta I. Second one, m2, a minus beta I. This is the case when b square less than 4ac. So whenever you get the complex roots, so the general solution you can write as y equal to exponent alpha x, so this is the real numbers, multiply a cos beta x, where beta is a complex number, a cos beta x plus b sin beta x. So the case 1, case 2, and case 3 are very important, the roots for equation 2. Equation number 4, am square plus bm plus c. So you must remember each case, case 1, case 2, and case 3. So methods of solution. Step 1, replace d square y over dx square equal to m square, dy over dx equal to m, and y equal to 1 into the given differential equation. Step number 2, after you have replaced, now you must state what is your auxiliary equation. So you have changed the equation 2 to equation 4. Step number 3, find the roots of auxiliary equation. So you solve the quadratic equation that you get, find the values of m. Step number 4, identify the type of root. So whether you get case 1, case 2, or case 3. After you have identified the type of root, now you can find the general solution. Step number 5, and lastly, step number 6. If the initial condition is given, you can obtain the unknown by substituting the value. So you get a particular solution. Let's see example number 1. Solve the differential equation y double prime minus y prime minus 6y equal to 0. So step number 1. replace d square y over dx square equal to m square, dy over dx equal to m, and y equal to 1 into the given differential equation. So now we are going to change this equation into the auxiliary equation. So we will have m square minus m minus 6y equal to 0. So step number 2, state the auxiliary equation. So this is the auxiliary equation. So what is our auxiliary equation? M square minus m minus 6y equal to 0. Step number 3, find the roots of auxiliary equation. So for step number 3, because we have a quadratic equation, we can factorize this equation. So we have m minus 3 multiply m plus 2 equal to 0. So we have m equal to 3 and minus 2. So we have two values for m. m1 is 3, m2 is minus 3. Step number 4, identify the type of root. Because we have two different values for m, now this is case 1, real and distinct root, where m1 not equal to 0. Step number 5, find the general solution. So the general solution will be y equal to a exponent 3x m1 plus b exponent minus 2x. So this is m2. So this is our general solution. Example number 2. Solve the differential equation 3y double prime plus y prime equal to 0 when y0 equal to 1 and y prime 0 equal to minus 1. So first step is we change into auxiliary equation by using this replacement. D square y over dx square equal to m square, dy over dx equal to m, and y equal to 1. So this is y double prime. Y double prime you change into m square, y prime you change into m, and y equal 1. So we substitute into this equation. So we have 3m square plus m equal to 0. So what is our auxiliary equation? 3m square plus m equal to 0. Step number 3, find the roots of auxiliary equation. So the roots we can factorize m. So we have m 3m plus 1 equal to 0. So from the first equation, from this equation we can find the first one, m1 equal to 0, m2 equal to minus 1 over 3. So this is two values for m. So this is also case number 1, real and distinct root. Find the general solution. So the general solution will be a exponent 0x plus b exponent negative 1 over 3x. So because exponent 0x is 1, so you have y equal to a plus b exponent negative 1 over 3x. Step 6. If initial condition is given, then obtain the values of unknown constant to find the particular solution. So we know the initial condition. So initial condition is y0 equal to 1 and y prime 0 also equal to minus 1. So the solution we know so far is y equal to a plus b exponent minus 1 over 3x. So because the second initial condition we have y double prime, that means you need to differentiate the first solution. So differentiate the y, our solution, we get y prime. So differentiate A, we get 0. Differentiate B, exponent minus 1 over 3x, we get minus 1 over 3. Multiply B, exponent negative 1 over 3x. Right now, we are going to substitute the condition y0 equal to 1 into this equation and y prime 0 equal to minus 1 into this equation. So for y0 equal to 1, so when x equal to 0, y equal to 1, so we get 1 equal to a plus beta b exponent negative 1 over 3, 0. So you get a plus b. So this is first equation. So let's name this one equation number 1. When x equal to 0, then we have y prime equal to minus 1. So we have minus 1 equal to minus 1 over 3 b exponent negative 1 over 3, 0. So exponent will be 1. So we have minus 1 equal to minus 1 over 3 b. So b equal to positive 3. So this is equation number 2. So from equation number 2, we know that b equal to 3, then substitute back into this equation. So 1 equal to a plus 3. So a equal to 1 minus 3, which is equal to minus 2. So now we know a, we know b, and then we can write the solution. So y equal to minus 2 plus 3 exponent negative 1 over 3x. Example number 3. Solve the differential equation y double prime minus 8y prime plus 16y equal to 0. So first one is we need to change this equation into auxiliary equation. So we have y double prime minus 8y prime plus 16y equal to 0. So when you change into auxiliary equation, you will get m squared minus 8m plus 16 equal to 0. And then we are going to find the solution for this auxiliary equation. So for this equation, we can use a factorization. So we will have m minus 4 multiply m minus 4. So this one should be 0. So we have m equal to 4. So m1 is 4 and m2 also 4. So because this is both equation are the same, so this is case number 2. This is case number 2 where we have a real and equal root, m1 equal to m2. So what is our solution? Y equal to a plus bx in bracket exponent 4x. So that's it. This is our solution. And because we don't have any initial condition given, so the general solution will be this equation. Example number 4. Solve the differential equation y double prime plus 6y prime plus 9y equal to 0 when y0 equal to 1 and y prime 0 equal to 2. So this equation we have the initial condition. So we are going to solve this and substitute the initial condition to find the particular solution. So step number 1. Change this equation y double prime plus 6y prime plus 9y equal to 0 into auxiliary equation. So our auxiliary equation will be m squared plus 6m plus 9 equal to 0. And then factorizing this equation, so we get m plus 3 multiply m plus 3 equal to 0. So we have m equal to minus 3. So the solution for this equation, because this is case 2, real and equal, so we will have y equal to a plus bx exponent minus 3x. And then don't forget, we are given the initial condition, so we are going to substitute the initial condition into this equation. So the initial condition, first we have y0 equal to 1. Second condition, we have y prime 0. That means we need to differentiate this equation to get y prime. So let's differentiate this equation. So first, let's expand this equation. We have a exponent negative 3x plus bx exponent negative 3x. So now from this equation, I can find y prime. So y prime is a exponent negative 3x multiply minus 3 plus bx. So this one for differentiation, I need to use the product rule because this is a multiplication of u, which is bx, and v, exponent minus 3x. So by using product rule, I will have bx exponent negative 3x multiply minus 3 plus exponent minus 3x multiply b. So minus 3a exponent minus 3x minus 3bx exponent negative 3x plus b exponent minus 3x. So this is my y prime. Now we are going to substitute the initial condition. So we know that when x equal to 0, our y equal to 1. So remember y equal to a plus bx exponent negative 3x. So when x equal to 0, y equal to 1, so we have 1 equal to a plus b times 0, 0, exponent minus 3 times 0. So we have a equal to 1. So second condition, when x equal to 0, y prime equal to 2. So what is our y prime? So let's copy this one. So we have 2 equal to minus 3a multiply exponent negative 3 times 0 minus 3 b0 exponent minus 3 times 0 plus b exponent minus 3 times 0. So we have minus 3a minus 0 and plus b. So b equal to 2 plus 3a. Now we know that our a is 1, so b equal to 2 plus 3 times 1, 2 plus 3, so b is 5. So the general solution, the particular solution, a plus bx exponent negative 3x became a is 1, b is 5, so a plus 5x exponent minus 3x. So this is our particular solution. Example number 5. solve the differential equation y double prime plus 9y equal to 0. So change this equation into auxiliary equation. So we have y double prime plus 9y equal to 0. So we have m square plus 9 equal to 0. So from this equation we have m square equal to minus 9, and then m equal to square root of minus 9. So this one you can change by square root of 9 multiply square root of minus 1. So square root of 9 is positive, negative 3, square root minus 1 is I. So we have m equal to positive negative 3i. So this is the case number 3. So case number 3, we have a complex number. So we have here alpha equal to 0. So the real part we have 0, and the imaginary part, which is beta, equal to 3. So the solution will be exponent alpha x a cos beta x plus b sin beta x. So now we have exponent 0x a cos 3x plus b sin 3x. So exponent 0x is 1, so final answer is a cos 3x plus b sin 3x. Example number 6. Solve the differential equation y double prime plus y equal to 0. Given the condition y0 equal to 1, y prime 0 equal to 1. So we have y double prime plus y0 equal to 0. So change this equation into auxiliary equation. So we have m square plus 1. So this one equal to 0. So we have m square equal to minus 1. So m equal to positive negative square root minus 1. So square root minus 1 is I. So this is also case number 3. So we have alpha equal to 0 and beta equal to 1. So the solution will be exponent alpha x. So exponent 0x a cos beta x, so a cos x plus b sin beta x. So this is the solution, a cos x plus b sin x. Alright, now we have a general solution. So we are going to substitute the initial condition given y0 equal to 2, y prime 0 equal to 1. So we have y0 equal to 2, y prime 0 equal to 1. We have a cos x plus b sin x. So y prime will be, differentiate cos, you get minus sine. Differentiate sine, we get cos. So we have minus a sin x plus b cos x. Alright, for first condition y0 equal to 2, so when x equal to 0, y equal to 2, so we have 2 equal to a cos 0 plus b sin 0. So cos 0 is 1, so 2 equal to a multiply 1, sin 0 is 0. So we have a equal to 2. Second condition, y prime 0 equal to 1. So 1 equal to minus a sin 0 plus b cos 0. So sine 0 is 0, cos 0 is 1. So b equal to 1. Hence our solution will be a is 2 cos x, b is 1, so 2 cos x plus sine x. Alright, that's all for chapter 2 for homogeneous equation. So do the exercise on this page, and then I will give you the answer for the solution or on the next video.